In 79 AD, Mount Vesuvius erupted and buried the ancient city of Pompeii beneath several tons of molten lava and hot ash. The loss of life and destruction was catastrophic and remains one of the most infamous natural disasters ever seen. Since then, scientists have been trying to predict when the next super eruption might occur. Now, a new study has revealed that, by looking at the chemical makeup of the magma, researchers could predict just how explosive a volcano could be. The research shows that the type of reaction depends on the chemistry of the magma. The presence of certain chemicals alters the viscosity of the magma. A highly viscous, thick and slow-moving magma is more likely to explode violently than a fluid magma. When magma rises to the surface, the water becomes bubbles and this increases the pressure. In thick and slow-moving magma, the pressure cannot escape and therefore builds up before it blows violently. In fast-moving, fluid magma, the bubbles can escape, and this causes an effusive eruption, which is far less violent and dangerous. Aluminium, sodium, and potassium play a big role in how viscous the magma is. Knowing the chemical composition allows for an estimate of how explosive and damaging a volcanic eruption will be. Scientists say certain chemicals alter the viscosity of the magma, which has a direct impact on its explosiveness. Dr. Genova, an expert in experimental volcanology and petrology at the University of Bristol and co-author of the study, said, "We have found a tipping point at which magmas fluidise or stiffen. If the viscosity of the magma is very high, think about honey in the fridge, bubbles will not be able to grow easily, and they will develop an extremely high over pressure." On the other hand, if the magma viscosity decreases, bubbles can grow and escape calmly, like a bottle of sparkling water, said Dr. Genova. We found that changes in sodium, potassium, aluminium, and iron content affect the magma viscosity and govern the eruptive behavior, he continued. More potassium will result in a more explosive reaction, whereas more sodium will likely cause a more gentle eruption. They also found that an infinitesimal change in aluminium content can also dramatically affect the outcome. The changes in chemical concentration happens at the nanoparticle level, and such fine margins could explain why some volcanoes exhibit both behaviors in a short period of time. Previously, it was unknown why the same volcano can sometimes erupt effusively and sometimes explosively. "We have presented evidence to solve this mystery," says Genova. Effusive and explosive reactions are wildly different and have hugely different impacts on human life. Whilst volcanic eruptions cannot be stopped, knowing how powerful they are going to be would provide invaluable information to minimize the risk to human life. Whilst the information from this study provides new insight into how eruptions work and what triggers the most damaging ones, timing volcanic systems and predicting when they will erupt is still extremely difficult. In future research, the scientists hope to focus on understanding how far a volcanic system is from such a tipping point. Genova said, "We need to develop new infrastructure to mimic magma physical conditions in the laboratory." This means that we need to work at very high pressure, 2000 times ambient pressure, and high temperature, up to 1400 degrees Celsius. This study allows scientists to know what to look for in the warning signs. Looking at how that can be applied practically to an erupting volcano is the next step.